Most people associate Isaac Newton with figuring out how gravity affects the motion of Earth and the planets. But there's a much less known hero in this story. A man named Johannes Kepler spent nearly a decade of his life painstakingly compiling detailed observation of the motions of the planets around the Sun and deduced laws that apply to them and to the Earth. Kepler discovered 3 laws that govern the movement of celestial objects. Kepler figured out that all planets trace an elliptical path around the Sun, with the Sun existing at either of the 2 focuses or foci. This was Kepler's first law, or the law of orbits. This might seem obvious, but a lot of really smart people believed that orbits were perfectly circular, which was wrong. Kepler next discovered a curious property of the plane in which a planet orbits a star. This is also called the law of areas. Simply put, the area swept by an orbit by planet are equal for equal intervals of time. Let's say the Earth is at the far point of its orbit. It will trace out a particular hour marked in green. If we picked another point in the Earth's orbit many months later and tracked the Earth for the same interval of time, it would again trace out the same area. This is because, unlike what would happen in a purely circular orbit, in an elliptical orbit, the speed of the planet varies. Far from the star, the planet is moving slowly, but it traces a considerable area on the orbital plane because the distance from the Sun to the Earth is greater. Closer in, the planet traces a longer arc in the same time, but also has a smaller radius of orbit. This means the area are equal for equal length of time. This is followed by the law of periods, the third law discovered by Kepler, which state that the square of the time period denoted by p is proportional to the cube of the length of the semi-major axis of the orbit. This implies that the time taken to complete an orbit increases very quickly with an increase in the radius of the orbit. Let's look at the planets, Mercury and Earth. Mercury orbits 3 times closer to the Sun compared to the Earth, but it is also completing its orbit 4 times faster. It is also important to note that the law of periods was vital to the insight. Another great mind gained into planetary motion. Sir Isaac Newton would use these laws to formulate the theory of gravity. And that is what we'll discuss next. Did you know that Kepler's law apply not only to gravitational forces but also to all other inverse square law forces, and if due allowance is made for relativistic and quantum effects to the electromagnetic forces within the atom? What makes Kepler's work so important is how general his conclusions are and the scales at which his laws remain applicable.
Manorama Horizon, learning made simple.